Hello everyone, today we are going to study about the force on a point charge due to two or more other point charges, right? So if you're aware of Coulomb's law, which was my last video, that's good. If not, then you can check that before coming over here. So it is in continuation with that topic, okay? So there we are just dealing with point charges, which are limited to two. But what if there are more point charges? What would we do in that scenario? So let's go ahead and discuss about that. So let's say I have a charge Q1, okay, and it is a point charge, and then I have another charge whose magnitude is Q2. So basically I have Q1, and then I have second charge. I also have third charge. So what would be the situation over here? What would be the net force? Okay, what would be the net electrostatic force over here? So we will go ahead and dive deep into this topic, and let's look into one such problem. So the problem says there's a figure that shows 3-point charges that lie along the x-axis in a vacuum. Determine the magnitude and direction of the net electrostatic force on Q1. So the question says, can you find the net electrostatic force that is acting on the point charge Q1, given that there is second point charge and the third point charge as well, okay? So the thing is that to solve such a problem, we would like to go into solving this problem by doing it in parts, okay? So when you will solve it in parts, it will make more sense, okay? So let's see. So the first thing is that what we are going to do is, let me clear this one first. Okay, let's see. So first, let's find the force on charge 1 due to the charge 2. Okay, so for now I'm just ignoring that there is any other charge 3, third charge. So what is the charge Q2? What's the force on the charge Q1 due to charge 2? Sorry, the force on charge 1 due to the charge 2. Sorry, that was my bad. And you can do that by simply using this formula, which is called Coulomb's law, which is KQ1 Q2 on R square, right? So we are all aware of that. Do I know magnitude of Q1? Yes. So it is 3 microcoulomb. So micro means 3 into 10 to the power minus 6. Okay. So we'll write coulomb. And then do I know the magnitude of Q2? So it will go like this, minus 4. Again, it is microcoulomb. This symbol is called micro, which means 10 to the power minus 6, right? So when I will solve this, because I talked about this in detail in my previous video, you can check about that if you have any confusion. So here these brackets, they do one thing. Either the value is positive or it is negative, okay? So the outcome that comes out of this bracket is like this. It is always positive. It always gives you the absolute answer. So 4 into 10 to the power minus 6. Okay, so now let's see about R. So I have R, that is 0.20 meter. Okay, perfect. I have everything. So I'm going to plug the numbers over here in this formula. Q1, Q2 and R square. Okay, so let's see that. So what I'm going to do is K, I know it is 8.99. Let me make some space. I'll just write the numbers very quickly, okay? I hope you remember the formula. 8.99 into 10 to the power 9 times 3 into 10 to the power minus 6, which is my Q1, times 4 into 10 to the power minus 6, which is my Q2, right? And over here I have R squared. So let's get rid of this and quickly write 0.2 in 0.20 square, right? So when you will solve this, let's simplify. So I'm just going to make some space over here. Alright, so let's see. What you can do is you can simplify, you can multiply the numbers. I mean 8.99 into 3 times 4. Let me just quickly do that on my calculator. I have 8.99 times 3 times 4, that is 107.88. And then I have over here 10 to the power 9. And you know, when the bases are same like this, then we can, let's say I have 10 to the power a times 10 to the power b. So how it would go? It would be a plus b. Okay. So I can do the same thing over here, but in this case, let's say if you had minus over here, then it will go like this, minus b. So if I will simplify it a little bit, so a plus times minus b, the answer will be a minus b, 10 to the power a minus b. So I'm applying the same thing over here. So if I have, let's say, 10 to the power minus c as well, so I will have like this. So it can continue, right? So I will have minus c. I hope it makes sense. Or you can simply punch in the numbers in your calculator, okay? So 0.2 times 0.2, so that gives me 0.0, right? So you can put these numbers in the calculator. Let's say I have 107.88 divided by 0.04, so which is 2,697. And let's see what we got over here. So I have 9 minus 6 minus 6. So I have over here minus 3. So if I have to write in terms of numbers, so I will move this in the form of decimal. So I will get something like this, 2.697 or simply 2.7 newtons, right? Because at the end of the day, we are just finding force, right? We can stop the video over here and we can now try calculating similarly following the same procedure the force on the charged particle 1 due to the charged particle 3. Okay, so you can go ahead and try that. Pause the video over here, use this formula kq1 q3, mind that we have the charge that is involved in this case is q3. So feel free to solve it and come back and check your answer. Okay, so let's plug in the numbers over here. So let me make some space and let me first start by writing Q1. Q1, as you already know, it is 3 coulombs. So don't forget the 10 to the power minus 6. I have my Q value, Q1 value ready. Let's see Q3 this time. I have minus 7 into 10 to the power minus 6. So answer would be 7 into 10 to the power minus 6. R in this scenario is just 0.15. Okay. So I'm just going to do one thing. I'm going to write the numbers over here. Okay. So it will just save me some time. Okay. So the key value is same, right? I hope you understand that. That's a constant. So I'll put the Q1, which is 3 into 10 to the power minus 6. Q3 is 7 into 10 to the power minus 6. And in the denominator, we have got 0.15 square, right? So you can punch in these numbers in your calculator. Feel free to do so and come up with the answer. So what I'll do is, let me simplify a little bit. So I have my calculator 8.99 times 3 times 7. So I just got the numbers over here. I have multiplied these numbers and I got 188.79 times. I have 10 to the power 9 minus 6 minus 6. We already cleared the concept over here. And then in the denominator I have 0.15 times 0.15, which is 0.0225, right? So let's simplify. I'll just quickly write F13. So I have 188.79. I'll round in the end. Okay. So 188.79 divided by 0.0225. So I got something like this. Let me write this number 8390.66, and it continues. And then in the 10 to the power, I got this. So that means I'll move my decimal to 3 places towards the left side. So I've got 8.39 Newton, or roughly 8.4 newtons, right? So this is what I have. Now the next step, because I have to find the total electric force or net electric force, electrostatic force on the charge 1. So what we have got so far, we have got force on the first charge due to the second charge. We have got force on the first charge due to the third charge. What would be net force? So net force will be the sum of this, right? So F12 plus F13. So feel free to put in the numbers. Okay. Now, before moving ahead, I'll just write the numbers over here, because if you see that over here, because force is a vector quantity, right? So we just got 2.7 newtons, and then it is 8.4 newtons, right? So let's talk about the directions a little bit, because force is a vector quantity, right? And direction is important. So the force exerted on charge Q1 by Q2, if you notice the charges Q1 and Q2, they are of opposite signs, right? They attract one another. So there's a force is it points towards the left side. Okay. And similarly, if you notice Q1 and Q3 in this scenario, they are also of opposite nature, and then they will be also attractive, right? And they will be pointing, the force will be pointing towards the right side. Okay. Then the vector sum. So if you notice over here, let me draw it in this way. For example, let's say this is your x-axis, right? And Q1 is lying on the origin. So this one is acting in this direction. The direction of the force is towards this side. So this is the positive x-axis, and the force on this side is acting towards the left side. This is your negative x-axis, right? So you will have -1, -2. So that means it is a good idea that F12, I put a negative sign. I hope it makes sense, because you have to consider the direction as well. And it is coming out to be negative. And similarly, this is on the positive side, right? So this will be plus. So this is plus, we can write plus, okay? So this is important to consider, because here it would give you the correct answer. If you don't consider the signs, okay, then the answer would be wrong. So I will plug in the number over here, which is -2.7 plus 8.4. Makes sense? So solving that on the calculator, it gives me 5.7 newtons, a plus. Okay, so that means the plus sign indicates that the net force will be it is pointing in the right direction. Okay, it is pointing, the net force will be in the right direction. I hope that makes sense. Now let's see what we have next. So is the whole solution along with the explanation. You can pause it for a while, read everything, okay? And I hope that should make sense so far. Now let's dig into the next question. This figure on the right hand side, it shows 3-point charges that lie in the x and y plane. Now the things are getting a bit more interesting. Initially, the question we just did, the question, all the charges, they were lying on one direction, on one axis. Let's say it was x-axis. Now what if instead of like this, there are one charge is here, other charge is here, but the third charge is here, right? So that means here you have one axis and then you also have the second axis, right? So that means here you are dealing with the two dimensions, x and y plane. So what would we be doing in that scenario? So let's start learning about that. So the force exerted on the charge Q1 by the charge Q2, okay, is, let's see this, Q1 and charge Q2. The force which is exerted on the, so again we have to find the net electrostatic force on the charge Q1. So the second charge is present, so the Q1 will feel the force due to its presence, right? So force on charge 1 due to the second charge, so that is F12. So F12 would be K Q1 Q2 upon R square, right? So this will be given by your Coulomb's law, right? And also because if you notice the signs over here, this is -6 and this is +4, right? Microcoulomb. So let me write it quickly. So Q1 is +4 microcoulombs, which is 10 to the power -6, and Q2 is -6 into 10 to the power -6 coulomb, right? We already discussed the sign, which is mu. It means 10 to the power -6, right? Now, what is R? This R is given to be R12. It's better to write it like this, R12, because if you see over here, there will be some component of this vector in this direction, and there will be the x component, there will be the y component, okay? Now what is R12? R12 is 0.15. So this formula over here will help me determine the magnitude. Makes sense? It will help me determine the magnitude. So let's go ahead and jump right in to find the magnitude. So F12, 8.99 into 10 to the power 9. Q1 is 4 into 10 to the power -6. You can pause the video over here. You can try doing the calculation on your own and then come back and check if you did it right. So R12, 0.15 square. So the procedure I follow, I multiply the numbers. Okay, I like to simplify a little bit and then I like to collect my powers. 9 minus 6 minus 6 and 0.15 square. Oh, at this time, let me pull out my calculator. 8.99 times 4 times 6, right? So I got 215.76. Okay, and let's see, 0.15 square. So that is 0.0225. Yeah, there's a decimal over here. So I've got something like this. Let me just do the quick calculation. 215.76 divided by 0.0225. Okay, I've got this number 9589.33 and then 10 to the power -3 to the solve it. So I'll move the decimal place like this. If it is plus, then the decimal will move in this direction. If negative, it moves in the opposite direction, that is left. So 9.58. Okay, so I will round it in the end. Let's say it is 9.6 newtons. So yeah, we got our let's say the magnitude in this case. I'm going to quickly get rid of all the drawings over here, and I would like to talk about the components over here. So this component, this force, which is F12, right? So F12, this force, it has a x component, and then it will have some y component, because your force is like this, the force vector is like this. So from your prior knowledge, we must be knowing that if there is a vector like this, then it has some x component and some y component. So I will say that I have F12 in the x-axis, right? Which I can say, let's say like this, and then I have F12 in the y direction. So is it okay to write F12 cos of theta as my x component and F12 sine of theta as my y component, right? Theta is given to me. What is theta? Theta is 73 degrees. I like to set up over here a nice table so that you can understand what's going on. So first, let's write obviously force over here, and then let's talk about the x component and then the y component, right? So that makes some lines like this. Now what I have over here is I have one force which is F12, and what would be the x component of this force? Okay, I have, sorry, let me undo that. Yeah, I have this vector over here F12, which you see. So it has a component F12 cos theta. Let's calculate over here. I'll directly plug in the number over here, F12 cos of theta. F12, do you remember what we got? We got 9.6, and then cos of 73 degrees. So you can, let me plug in the numbers. Cos 73 times 9.6, it gives me 2.8 Newton. So I found the x component in this case. So that is 2.8, right? And similarly, you can pause here. Go ahead and find the y component. What would be the y component of this force vector? Because it has some component along the y-axis as well. So F12 y component will be given as F12 sine of theta. F12 is 9.6, do you remember? And then sine 73. Let me plug in these numbers in the calculator. I have sine 73 times 9.6. It is 9.2. It is 9.2. Make sense? Now let's talk about, let me make some space on this side. Let's look at another point charge. Okay, we are done with this charge, which is present on this side, like this. There's another charge, Q3. But notice one thing, this charge is in line with this charge. That means what I'm trying to say is it is on the same axis. It is on the x-axis only. Okay, so that means if it is lying on the x-axis, its y component is 0. That made my life a little bit easier. So let me write. What I'm going to do is now I'm trying to find the effect on the charge 1 due to the charge 3, right? And interestingly, I found over here, because the Q3 is also lying on the x-axis, Q1 is also on the x-axis, the force is essentially one dimension, like the previous question we just did. Okay, so I don't need to worry about the y component, because on x-axis the height of y is 0, the y component is 0, y is 0. So let's quickly do that and write 0 over here. Let's find the x component. So how do you find the x component? So you can do like this because we are doing force on the first charge due to the third charge. Let's find the magnitude. You can pause. You can try on your own and try getting your hands around the Coulomb law, using it, gaining some kind of confidence. 8.99 into 10 to the power 9. Q1 is 4 into 10 to the power minus 6. Q2 is minus 5. So I have told you these are brackets out of which you just get the positive number. So you don't need to worry about the negative number. It will be 5. And r square. What is r square? So here it will be r13. So it is 0.10 square, right? So feel free to do the calculation. Okay, let me do that quickly over here. So you know how we will go. 8.99 times 4 times 5, which is 20, times 8.99, which is 179.8, times 10 to the power minus 3 upon 0.1 times 0.1, which is 0.01. So I will have, so let me simplify a little bit over here. I have 10 to the power minus 2 in the denominator. So let me just tell you one more thing. If you have 10 to the power a, sorry, this is a bad a, but it is a, just consider that. Let me do that nicely. So I have 10 to the power a upon 10 to the power b. So the formula says it is a minus b. If we have multiplication, 10 to the power a times 10 to the power b, what happens? It is equal to a plus b. But if you have division, then it goes as a minus b. So let's try to do that over here. Okay. So let me make some space on this side. And I have 10 to the power minus 3 on the top. I have 10 to the power minus 3, 2. So 0.01 can be written as 10 to the power minus 2. So the formula says I have minus 3, this is my a, minus, and this is my b. Okay. So this is my b, this is my a, right? So it is a minus b. So interestingly, both of my powers are negative. So don't worry. Let's do some maths. Let's do some simplification. So minus 3. So when this minus will multiply over here, it will be plus. So I have 10 to the power minus 1. So I will solve and write 10 to the power minus 1. I even don't need to like calculate this part. So 179.8 into 10 to the power minus 1. That means this decimal will move one place towards the left side. I have something like this. Can I write it like 18 newtons? Yes, sure, we can do that, right? So it's nice to write 18 newtons. So what I have over here is, let me clear everything up. I have F13 because it's a vector, right? So it is 18 newtons, the magnitude I got. And because you have to find the x component, this is the x component, right? If you go ahead and do x component, it will be F13 cos of theta, and the angle between the two of them is 0. F13 cos of 0, it's your wish. You want to do cos 0 is 1, so the answer will be 18. Sorry, I should not have, erased. Let me see if I can undo. Okay. I'm just trying to do undo because I want to want my table back, which I drew for the components. Yes, this is what I was looking for. And yeah, let me quickly plug in the number over here I got for the x part, which is 18, right? So perfect. Here we have our x components and y components. And how do we find the net force in this case, where we have x components and y components? So what you will do is you will add all the x components, right? And you will add all the x components. So let's do that. So I will find the net force, and then let's say my total x component now becomes 2.8. I can roughly consider as 3 to make my life a little bit easier. It is 18 plus 3, which is 21. And on this side, my total y component is 9.2. Okay. So I have got over here let's say I've got Fx, the total force in the x direction 21, and the total force in the y direction 9.2. So what we have over here is, how do we find the force? Is if I have like this, I have one vector in this direction, which is x, and this is Fy in this direction. So what will be the net or resultant force? If you remember from your prior grades, it can be done like this, right? So do you have f of x squared? Yes, we do have actually. So let's quickly plug in the numbers. What is f of x? It is not f, it is fx. Sorry, I'm just saying f of x. That's wrong. It is 21. 21x, 21 square, right? What is fy value? Force in the y direction. It is 9.2, right? So you can do this calculation. So let me do that with you. So we have over here, let me make some space on this side. Okay, nice. So let me do 21 square. So that would be 441 plus, let me do 9.2 square. 9.2 times 9.2, perfect. We got 84.64, right? And then let me add these two numbers. So my next step would be to add these two numbers, right? So that would be, let me write on this side, which is square root of 5 to 5.64, and square root of this number is, let me do that real quick, 22.9. Okay, perfect. And you do know 22.9 is, you can write it as 23, right? You can write it as 23 newtons. And this is your F vector, right? This is the magnitude, this is not the vector. I'm sorry, you can just write F, right? So I'm just going to clear this up nice and smooth. And going to write that I successfully found the magnitude, which is 23. Let's talk about the directions. It will be this direction, this direction, this direction, which direction? What will be the angle? What will be the direction? So interestingly, if you know that, you can find the theta, okay? If you know that the total x component of your force, the total y component of your force, and then in which direction your resultant vector will be. So the theta you can find by using this formula, which is tan inverse f of y upon f of x. Okay, so we have to just do the tan inverse of this number. What is f of y? Fy, sorry, wherever I say fy, sorry about that. It is 9.2. So there's a lot of difference. I don't want to go into details and confuse you, but it is just Fy, okay? Force in the y direction, so 9.2, and Fx, it is 21. So let me do that maths real quick. I'm going to simplify over here. I'm going to divide 9.2 with 21. 9.2 divided by 21 is 0.438. So I got over here tan inverse 0.438. Okay, so if you do the tan inverse of this number, that would be 24 degrees. That would be 24 degrees. So this is the direction. Okay, so this is what we got, the net electrostatic force on the charge Q1. It is 23, the magnitude, and the angle is 24 degrees. Okay, perfect. So this is it for this video, and we'll continue reading more about this stuff in the next video. Thank you.